have the subnet mask. For example, we only configured 192.168.1.1. This means that the first 24 bits, because this is the class C networks, are the network bits, and the last 1 bits, okay, is the for example, the last 1 octet, okay, last 8 bits are the host bits, you know it, okay. But here, as you can see, subnet mask can say us that we have 16 bits of networks and 16 bits of the hosts, you know it. Because of that, in classless networks, we need, and it is mandatory, we should configure the subnet mask. In classful networks, we didn't have this option. Okay, now, what is the default subnet mask? Maybe you encounter with this definition in some cases. Let me to talk about that. The default subnet mask. Okay, when you are using, for example, for address 10.1.1.1, a subnet mask with the correlation of the classful with the, for example, same concept of classful networks 255.0.0.0, you know that 10.1.1 is one of the IP addresses of the class A, okay, in the classful networks also. When here now, when in classless networks we are using 255, this means that 8 first bits of this IP address is the network bit, okay, this is the network bit, and also after that the second octet is the host bit, third octet is the host bits, and fourth octet is the host bit. You know that here is we have the same condition of the classful networks. Okay, when you are using for addresses, some addresses, for example, in class A, okay, the 255.0.0.0, this is the default subnet mask. On in classful 255.255.0, for example, this examples 172.16.0.0, 255.255.0.0, this is the default subnet mask, because here you have the same condition of the classful networks. And also after that 192.168.1.0, for example, or 1.1, here when you are using 255.255.255.0 in subnet mask, this means that you are using the same subnet mask of the with the same result of classful networks. 3 first octet are network bits and the last octet is the host bits. Because of that, we call the 255.0.0 subnet mask and also 255.255.0.0 and also 255.255.255.0 subnet mask as default subnet mask. This is the default subnet mask. This is only a definition. It's not so important. In some cases, maybe you encounter with these definitions, but it's good to understand these for analogies or these definitions. Okay, default subnet mask means 8 bit of the networks, and 8 bits of the IP address is network, 16 bits of the IP address is the network, are the network bits, and 24 bits of the IP address are the, for example, network bits. Okay, this is the default subnet mask. But we have one important result about the subnet mask. Let me to talk about this. Look at here. You know that in subnet mask we have a definition. Let me to copy this definition. This is the definition and usage of the subnet mask. We can write it here. In subnet mask we have the 1 and 0. 1 means network bits in IP, and the 0 means the correlating bits in the IP address is this host bit. You know it, okay? And also you know that in IP address we have 2 parts: network address, okay, network, and then host. And we can't configure, we can't use one IP address, for example, with this format. Look at here: network, then host, then for example, again network, again host. Okay, this means that when you are assigning one IP address, when you are using one IP address, some first part of the IP address are the network bits. After that we have the host bit, and after that again we can't use another network bit. We have only again host bits. Okay, this is so important. Why? Look at here. You know that In subnet mask, we have 1 and 0. You cannot use the alternative 1 and 0 in subnet mask. For example, you know that until now we use 255.0.0.0 as a subnet mask of, for example, 10, 10, 10, 10. Okay, but this is okay. This means that the first octet is the for example, network bit, the second, third, and fourth octets are host bits. It's okay. But assume that I'm using this subnet mask. Look at here. 10, 10, 10, 10 with the subnet mask of 2550, again 2550. It is not okay. Why? Because here you say that the first octet is network bit, the second octet is host bit, again the third octet is network bit, and the fourth octet is host bit, and this is not okay. Okay, this is not possible. When you reach to the host bits, to the end of the IP address, you need to use again host bits. You can't use the alternating 1s and 0 in the subnet mask. You know that the subnet mask equivalent with this value is, let me to write here, quad 1 means 81, then quad 0 80, again quad 1, and then 0 0 0 0 0 0 0. Here, as you can see, we have alternating 1s and 0. Okay, this is not possible. In subnet mask, first we need to use 1, and after that, when you reach to 0, you should use all of the bits to the end of the subnet mask 0. You know it, okay? And after that, let me to give you one other important notation about the subnet mask. And that is for some subnet mask maybe you didn't encounter with them until now. Look at here. You know that until now we configured only these three subnet masks: 255.0.0.0, 255.255.0, then 0, 255.255.0.0, okay, 255.255.255.0. The three default subnet masks. But we have another subnet mask. Let me talk about them. Look at here. For example, we have one IP address 10.1.1.1, okay, and the subnet mask is 255.255, okay, 255.255, again 255, again 128. What does it mean? What is the meaning of the 128? It's so easy. Let me to write these two value in the binary format. For example, 10.1.1. 10.1.1 equal to the quad 0, 10.10. This is the 10, and then 1, quad 0, then 0, 0, 0, 1, again the same value, quad 0, 0, 0, 0, 1, again quad 0, 0, 0, 0, 1. This is the 10.1.1.1 in binary. After that, let me to write the subnet mask 81 dot, again 81 dot, again 81 dot. Look at here, 128 means only the first bit is the network bit and other bits are the host bits. 128, this is equivalent to the 128. This means that in this IP address, okay, we have different conditions. In this IP address, the first 25 bits, not 24 bits, are the network bits. Look at here, this is the network bit, this is the network bit, and this is the network bit also. Here we have one network bit and 7 host bits, okay? This is the usage of the classless networks. In classless networks, we don't we don't need to use only the 8 or 16 or 24 bits for network or host. Okay, here you have 25 bits of networks and also 7 bits of the host. It's okay. We don't have any problem with this subnet mask. Look at here, 25 here from here. And we have 25 bits of the networks, and after that 7 bits of the host. It's okay. Because of that, in the subnet mask, you can use another values, for example, 128 or another values. But don't forget that you can't use alternating 1s and 0. In the octets of subnet mask, you can use only this value. Let me to write here. You can use, for example, 80 in one octet of the subnet mask, such as this example. Look at here, we have 80. This means that all of the for for example, equivalent bits or in the IP address are the host bits. It's okay, and you know that this is equal to 0. Also, if you want, you can use 1 then 70, such as this example means the first bit is the network bit and the other 7 bits are the for example host bits. This is equivalent to 128 in decimal. After that, we can use 1 1 again 60. This means that 2 first bit of the IP address is the network bits, okay, in that octet, and after that other 6 bits are the host bits. This equal to the 192. This means that in octets of the subnet mask you can see 0, 128, 192. After that 111 again 50. This is equivalent to 224. Again 1111 quad 0 means for example 240. After that 5130 means 248. Again 6120, this means 252. After that 710, 254, and finally 8 ones, this means that 255. This means that we can see only these values in the octets of the subnet mask. Assume that I'm using this value 255, 255, 255, then 193. Okay, this is not correct. This is incorrect. Let me to talk about that. Look at here. This means that 81. This is the 81 dot again 81. Again 81. After that 193 11 0 0 0 0 0 then 1. This is the 193. Okay, as you can see with this subnet mask we say that the first 2 bits of the last octet are the network bits, and then we have 5 host bits, and after that again we have 1 network bit. You know that this is not possible. Okay, because of that in subnet mask you can see you will have only these values. Okay, for example the values of the 0, 128, 192, 224, 240, 248, 252, 254, and 255. You will learn about this subnet mask more than this, but let me to say that until now we learned about the subnet mask and its function. The function of subnet mask is identifying the network part and also the host part of one IP address. This is the first result. And after that we can use